All right, well, hello everyone, and welcome to our Exam 1 review session. So here's our goal for this review session video. First, we will review the information in the study guide and cover what kinds of questions and topics will be on our exam. All the information we cover is found in our study guide. We'll review some examples further in this video as well. Next, really our goal here is for you to identify specific topics which you know and specific topics which you want to review further. So as we go through each topic one by one, I highly recommend that you make note of the topics that you know well, and if there's anything you see that you want to review further or that maybe you're not quite comfortable with, please make note of those topics. And remember, if you need, you're also welcome to reach out for help in office hours or by email and Discord in order to get any last minute questions answered. And then finally, we will practice some representative questions that are on the sample exam so you can get an idea of the types of questions that might be asked. Okay, so the first item in our study guide is really more of a reminder to read the instructions and read the questions carefully. Sometimes students make mistakes and lose points, not because they don't know the material, but because they failed to follow directions. And so please make sure that for each question on the exam, you read the question very carefully and make sure you do everything the question asks. For example, some of the questions will ask you to give an answer and then explain why. And you need to make sure you remember to explain why. So please do read the instructions very carefully and make sure that you answer the question fully and correctly. Next item on our study guide is the engineering majors and functions. And we've done a few examples of this already, but we'll do another one in just a moment. These are the questions such as, who would you hire to do a certain engineering task? And you'll want to be ready to explain your reasoning when answering these questions. For example, if I asked you what engineering functions are needed in order to build a skyscraper, you would want to be able to identify some types of engineering majors and types of engineering functions which would be useful for that task. So a couple things you'll want to make sure is make sure you have reviewed our Module 1 and Module 2 handouts so that you have a complete list of all the engineering functions and majors ready to go. For this question, the majors and functions must come from the list covered in class. So for example, if we were answering that question about who would you hire to design and build a skyscraper, if you said that you wanted to hire someone whose function was something like drafting, that is not one of the specific functions that we covered in class, so that would not be an acceptable answer. But you could choose a function such as design or manufacturing or one of the others who we did cover. So please be aware of this point and make sure that the functions and majors you specify are the ones that we specifically covered in lecture. And make sure you can explain why. That will be part of the question, not just simply saying, yeah, I want to hire a mechanical engineer with test function, but why do you need that specific person? What value do they bring to your project? Let's do a quick example question before we move on. So suppose we are looking at that skyscraper problem, and we are allowed to hire 3 engineers to help us build a skyscraper. So first part of the question asks, what 3 engineering majors would we choose in order for this project to be successful? So in this case, make sure that you choose 3 different majors, but there's many options you could choose. For example, you might choose architectural. You might consider a civil engineer, a mechanical engineer. You might consider electrical. And you might even consider someone like materials if you have some sort of sustainability thing going on. or even an environmental engineer if you wanted to analyze a footprint. So there's many different engineering majors you could potentially choose for this project. And then in the next part of the question, you might be asked to explain why you would choose each of these majors and what knowledge or skills you would need each major to bring. So for example, maybe you chose a civil engineer, and maybe your reason for choosing the civil engineer is you need the civil engineer's knowledge about things like the building infrastructure, structural rules, and construction projects in order to help the construction progress smoothly. So I'm not looking for a huge essay here, just 1 to 2 sentences. It's basically just showing that you know what that major is and why it is needed for the project. Especially if you chose something like a materials engineer, initially that might seem like an unusual choice, but if you say that you want the building to be using energy efficient materials and sustainable materials, and the materials engineer has that expertise, then I would accept that as a valid answer. Okay, next one. List an engineering function which that person should have. So, for example, if one of our choices was an architectural engineer, what function would we want that person to have? You've probably noticed with this question that there's definitely more than one possible correct answer here. And I'm looking that you choose something that is valid and you give an explanation that shows you understand majors and functions. For example, we might want the architectural engineer to have the design function. Or maybe you want them to have the construction manufacturing function. Again, you can choose whatever makes sense in your mind as long as you are able to explain it and the explanation is valid for building a skyscraper. If you told me you wanted to hire a biomedical engineer with a research function, I probably would mark your answer incorrect because there's really no reason to have a biomedical engineer with research function unless this skyscraper happened to be a medical research facility, which it is not in this case. And then finally, last part of the question might ask you to explain why you chose those functions. And so one example here, suppose you had an electrical engineer. You could say you would want the electrical engineer to have expertise in the analysis function so they could run simulations and make sure the project will work. Skyscraper is going to have a lot of electrical lines and utilities running in there, and you may need to run simulations to help make sure everything will be okay. Or you might need that architectural engineer to have the design function because the architectural engineer has a lot of knowledge about skyscrapers and they can help make sure that whatever design is being used meets the latest building codes and will be structurally acceptable. All right, so that's it for majors and functions. And remember, you're more than welcome to reach out if you have questions on those topics. Again, I recommend really reviewing our week 1 and week 2 materials. And also make sure that as you go through majors and functions, just make sure you choose a major and function from the list that we covered during class. All right, so next item is our multiple choice questions. And so really good place to start is make sure you understand the quiz questions and homework questions that we've had, especially any you might have gotten wrong. I might get lazy and put something very similar to your quiz questions on the exam as well. And the questions can potentially come both from the lecture topics as well as the lab. And so I recommend you pay attention to the lecture handouts that you've been filling out as well as our lab topics. And notice there could also be some questions about resumes, cover letters, and Excel. So make sure you review those labs as well, including things like formulas and also the best practices for resumes and cover letters. All right, our next item is unit conversions. And so there will definitely be some questions about unit conversions and how to do problems with dimensional analysis. And so we'll go through and review a few quick tips. First is making sure you know how to make conversion factors correctly, making sure you know how to do dimensional analysis, making sure your units cancel out, and then finally making sure that you review answers carefully and just reading the question really, really carefully as you go. All right, so let's go ahead and go through a few things to commonly watch out for here. And as we mentioned, you want to make sure that your conversion factors are correct and your unwanted units cancel. You also want to use your spidey sense. Does your final answer seem reasonable? And make sure your units look correct when you're finished. If your answer seems too big or too small, maybe you accidentally had something incorrect in your calculation. And finally, if you are completing that unit conversion, make sure you multiply and divide correctly at the end, and be careful of any small errors in the calculations. All right, so first, making sure you set up unit conversion factors properly. Here's an example. We know that there are 365 days in 1 year. So please note we could say 1 year is 365 days like this, or 365 days per 1 year. Both of these would not be correct. All right, next one. Make sure your units cancel. So again, here's a quick example. Suppose we wanted to convert days into years. We could take 57 days times 1 year divided by 365 days, and notice days cancels correctly, and we are left with a final answer with years units. But in this example here, you see if days does not cancel, then we'll actually end up with an incorrect result. All right, let's do a couple quick review questions before we move on. I encourage you to try pausing the video and see if you can correctly answer these before looking at my answer. So first one, here we want to convert 6.5 feet into inches. So which conversion factor would we use? So the thing you want to think about here is we want to get rid of feet. So feet should be on the bottom. And in this case, we know that there are 12 inches per 1 foot. So the correct answer here should be choice C. Because if we multiply by this conversion factor, then feet will cancel and we will result in inches. All right, let's go ahead and try one more here. So now we want to go all the way from feet to centimeters. And so far we have 6.5 feet multiplied by 12 inches per foot. So we're going to need to go from inches to centimeters. We know there are 2.54 centimeters in 1 inch. So if you'd like, pause the video and give this a try. All right, so remember, if we want our final answer to be in centimeters, we need to get rid of inches. So that means inches should be on the bottom and centimeters should be on the top. because that way this inches here will cancel out with our inches underneath. And in this case, we know there's 2.54 centimeters per 1 inch. So we should have 2.54 centimeters per 1 inch. Choice C is the correct answer. All right, next point is to use your spidey sense. Consider this example. Suppose we are trying to calculate the number of potatoes that will fit in an entire semi-truck. And we have this calculation here. A semi-truck is very large, right? It's basically a giant container. And this calculation is estimating that 2,100 potatoes can fit inside that semi-truck. And to me, this number seems awfully small because these semi-trucks, they can be, tens of feet wide. They can be approximately, roughly 10 feet high, maybe 30 to 40 feet long. And they can be potentially something like 6 to 8 feet wide. So this is a very large volume. So you should be able to fit a lot of potatoes in there. So question to you is there something wrong with this calculation? Take a moment and think about it. What do you think could be wrong here? All right, so the issue here is the conversion right here. The number of cubic inches per cubic foot. Be very careful. This is a common mistake that I see in these types of questions. Please remember that 1 cubic foot is not 12 cubic inches. 1 cubic foot is 12 to the third power cubic inches, or 1,728 cubic inches per cubic foot. So in fact, we should have calculated something more like 310,000 potatoes would fit in a semi-truck, which is a lot more potatoes. So please be very careful there. Make sure that you watch your units, especially this detail for the number of cubic inches per cubic foot. All right, and then last one, make sure you do your math correctly. When you finally finish the dimensional analysis, remember that you multiply all the numbers on the top of your calculation, and then you divide by the stuff on the bottom. So if you're trying to calculate how many Snickers bars you can eat in a year, in this case, we would multiply 1, 1,600, and 365, and then divide by 280 times 1 times 1, and that gives us about 2,086 Snickers bars per year. All right, so let's go ahead and look at a couple more quick practice problems before we move on. So if you'd like, I encourage you to take a moment and try this problem, pause the video, and then see how we solve it in the solution. Okay, so let's give this a try. So in this particular question, we are told to complete the dimensional analysis so that the undesired units cancel and we figure out how many cookies we can make with $250 worth of butter. So in this case, we know that each batch of cookies uses half a pound of butter. One batch makes 48 cookies. 2 pounds of butter costs $5, and we have $250 worth of butter. So initially, we can see that we have dollars, and the dollars are going to cancel. So right now, we have 2 pounds of butter. We want to get rid of pounds of butter. So that means we need to put pounds of butter on the bottom so that it will cancel with the one on top. And we know that 2 pounds of butter costs $5. We also know that one batch uses half a pound of butter. So if we put half a pound butter on the bottom and one batch on top, then notice pounds of butter will cancel. We're left with batches. Now we want to go from batches to cookies. So in order to get rid of batch, we need to multiply it by something with batch on the bottom. And we know one batch makes 48 cookies. So with 48 cookies per one batch, we could multiply by that conversion factor, and that would cancel out. So notice now the dimensional analysis is set up correctly. So our final answer would be equal to $250 times 2 pounds times 1 times 48 on the numerator, divided by $5 times 0.5 pounds butter on the bottom. And if we multiplied that through and then divided, we would determine the number of cookies we need. All right, with that, let's go ahead and move on to significant figures. All right, so our next item in the study guide was knowing how to do calculations and report answers with the correct number of significant figures. And so I definitely recommend that you review our handout from Module 3. And also our Lecture 5 notes have the significant figure information. Also, please be careful on the exam itself. You will see that if you are required to use significant figures for a question, the question on the exam will include a statement such as, write your answer with an appropriate number of significant figures. So for example, if there's an estimation question, you will need to write your estimate with the appropriate number of significant figures. All right, so in order to determine how many significant figures you have, make sure that you use the rules that we covered in Lecture 5. So basically, all non-zero digits do count toward the number of significant figures. Leading zeros, or zeros in front of the decimal, those do not count. And then notice these zeros in front of 0.000003 also do not count. Captive zeros, which are zeros between numbers, those do count. And trailing zeros count if the number contains a decimal. All right, so a couple reminders for significant figures. First, make sure that you report the correct number of significant figures when you are completing the estimation question. And we'll do an example of this a little later, but please do make sure you review that so you remember how to determine it. And make sure you read each question carefully. Once again, if you do need to use the correct number of significant digits, the question will say so in the question itself. All right, let's go ahead and try a couple quick dimensional analysis practice problems. So here, suppose we have a 737 MAX and it burns 0.7 gallons of fuel per second. Jet fuel has a density of 0.8 kilograms per liter, and there are 3.785 liters in 1 gallon. The question asks, how much does the mass of the jet decrease due to fuel being burned in kilograms per second? Show the calculation and all your work in the space below. And here, if we were asked to write the final answer with an appropriate number of significant digits, what would we write? Well, in this case, if we look at our question, the rule to remember is that when we are multiplying numbers, which we'll need to do in this question, the precision should match the number with the lowest number of significant digits. So in this case, notice we have 0.7 that has one significant figure. We have 0.8, which is one significant figure. And this one is 4 significant figures. But so notice because we're multiplying by these numbers with smaller numbers of significant digits, the final answer should just have one significant digit. So let's go ahead and try calculating this one. So we know we have 0.7 gallons of fuel per 1 second. We want to end up with kilograms per second. So the question is, how do we get rid of gallons and end up with kilograms? Well, we know that there are 3.785 liters in 1 gallon. So if we put gallon on the bottom and liters on the top, we can say, all right, well, we got 3.785 liters per 1 gallon. Gallons will cancel. Now we have liters. We want to go from liters per second to kilograms per second. And we know that jet fuel has a density of 0.8 kilograms per liter. So in this case, notice if we put liter on the bottom, that will cancel out. And so all we need to do is multiply these numbers through, and that will give us our final answer. So if we go ahead and multiply that through, we will determine that we'll have 2.1196 kilograms per second, but we need to round that to one significant digit. That will be about 2 kilograms per second of decrease in mass as the jet burns fuel. That's quite a bit. That's roughly a pound per second. All right, so you'll notice that I have also linked to some additional resources in Canvas, and I've listed some here as well. So if you do want additional practice with dimensional analysis, please do feel free to take a look at our resources in Canvas and also our past assignments. All right, so with that, we'll go ahead and move on to our next topic, which is estimation. So once again, as I noted earlier, there will be a problem on the exam where you need to use estimation. And the problem will be similar to the examples we have already done. So, important things to remember. Make sure that you read the question carefully. State your assumptions. Make sure you do your calculations and unit conversions correctly. You will be required to show all your work. And then finally, any information that you need will be provided to help you complete the problem. And the equations you need will be provided. So let's go ahead and take a look at this estimation question from our sample exam. Suppose you are trying to break the Guinness World Record for the largest batch of applesauce. And you are trying to fill a 20 feet square container with applesauce. So basically, we have a container that looks like this. It's a big square container, and all the dimensions are 20 feet. And so you want to estimate how many apples do you need to make this applesauce. Remember, on the exam, you're going to need to show all your work. You're going to want to make sure you report your estimate with the correct number of significant digits, and make sure that you explain your assumptions clearly. So let's look at our example. Here are some assumptions that you could choose to make for your applesauce. For example, you might choose to say that your apples are spheres that are 2.5 inches in diameter. You might also choose to assume that the stem, core, peel, and seeds are negligible, and that basically the entire 2.5-inch sphere apple can be directly used in the sauce. You can also assume, in this case, if you wanted, that the applesauce is made entirely of apples and that no sugar is added. It's one of those no sugar added applesauces. And maybe you assume the amount of cinnamon or other spices added is negligible. And another thing you could potentially assume is that the applesauce container is filled completely to the top with no overflow, and that there is no void space between the apples. So again, these are just some possible correct assumptions that you could choose to make for this question. Here's an example of how you could actually complete this calculation. So in this case, you could assume that your apple is using the volume 4/3 pi r cubed. And in this case, I actually had a small typo in this question. In this case, because I assumed my apple had a diameter of 2.5 inches, this value here should actually be 1.25 inches because it's 4/3 pi times the radius squared. Radius is half the diameter. So if we go ahead and correct that calculation, you will see that we actually get 1.25 to the third power times pi times 4 divided by 3. We actually end up with a smaller result of only 8.177 cubic inches for the apple. You might have thought at first glance that 65 seemed a little high, and that's because I had a small mistake in that calculation. But then here our container volume, if it's a 20-foot square, the volume will be 20 times 20 times 20, or 8,000 cubic feet. All right, so let's go ahead and finish up this calculation. So an 8.177 cubic inch apple, remember, if we want to convert cubic inches to cubic feet, remember that would be 1 cubic foot divided by 1,728 inches cubed. So that would give us a very small number of cubic feet, about 0.004732 cubic feet per apple. And if we have an 8,000 cubic feet container, we can divide these two values and we'll end up with quite a few apples, over 1.6 million apples. And in this case, remember, when reporting our final estimate, we would need to round, in this case, to two significant figures. That comes from our value of 2.5 inches in diameter. And in this case, the dimensions of the container, these 20s, these are exact values. So I would not count that toward the significant figure calculation because there's no error in that 20 feet. We know that our container is exactly 20 feet, but the 2.5-inch diameter for our apple, that does contain some error because that's just a rough estimate. So that's why we round to two significant digits here. All right, so by doing that, if we take that 1.69 million and round, we end up with about 1.7 million apples. And since we assumed that the core and peel were negligible, when really they probably do need to be cut out and removed, leaving us less apple, the real amount of apples, we could say, might actually be higher. All right, so that is it for the estimation question. The last item that we'll briefly cover is engineering and problem-solving questions. So please make sure you are prepared to answer questions about the problem-solving process and or the engineering design process. And you'll remember that we covered those procedures in lectures 7 and 8. So there could be some multiple choice or short answer questions about those steps. So make sure you remember those. All right, finally, the last topic for our exam study guide is the labs. And there will definitely be a few multiple choice questions covering material from our labs. And this includes resume good practices, cover letter good practices, and how to use Microsoft Excel, such as writing formulas for if statements, addition, multiplication, things like that. So please do make sure that you review the information in our lab handouts so that you are well prepared for this information. All right, so that is it for our exam review session. I hope you found this information helpful, and I hope that you see that this exam will really be a very straightforward exam. If you are prepared and you know the things on the study guide, you should find it to be one of the easier exams that you'll take in your engineering career. So please do make sure you're comfortable with the format and the topics in the study guide. Also, remember to review the practice exam and also the practice exam file upload question so that you can upload your work when you are finished. The exam will be open book and open notes, but closed internet resources. So please do make sure that you follow the rules and DVC's academic integrity policy. I've also included a few extra dimensional practice problems at the end of this presentation, so you can take a look at those if you'd like and try them on your own. All right, so that's it for our Exam 1 review session. I hope this was helpful for you all, and please do feel free to reach out if you have any more questions ahead of the exam. Also, remember to take a look at our study guide and practice exam for further information. Thanks everyone, and we will see you in the next video.